Hello, welcome. This is video number 6 of the C++ beginner tutorial. And last time, or actually for the last 3 videos, I believe we were talking about variables, the basics of a variable, the stuff you can assign to a variable, and what a variable does. I taught you basically one type of variable, which is called int, or the integer or whole number variable. Okay, now whole number variables can only store whole numbers, like 3, like 5, like 46, like negative 122, those kind of numbers. They can be negative, but they have to be whole. Okay, they cannot be fractional. They cannot be fractional at all. In fact, if you try to assign something to an integer variable, that would provide a fraction. So even if you would do something like this, let's say you have an int x right here. Okay, so you have int x, and then I'll say int x, or just x, equals 5.0 divided by 2.0. So according to what I taught you before, 5.0 divided by 2.0 should produce a 2.5. And it does. But guess what? When it's assigned back to x, though, that's where the problem happens, because x is an integer variable, and integer variables can only store whole numbers. So what happens is the 2.5 becomes 2 again, because 5 literally gets cut off and x becomes a 2, because x is not capable of storing anything but whole numbers. Okay, now this is a little boring, because in real life a lot of times we do have to deal with fractions. So I have to talk to you about different types that we can use to store other numbers and other things as well. So you probably will ask, how many types are there in C++? I'll tell you. Well, there are several answers to that question. There are hundreds of types in C++, if in one way of thinking about it, because types are user created a lot of times. So a lot of times, and you will create a lot of your own types for different things. Okay, but there are only a handful of what we call built-in types, or primitive types, that exist in C++ no matter what, that are part of the core language, right? And we just learned one of them, which is int, and I'm going to show you 4 others that are also built-in types, and then I'll show you some others that are like basically variations on these built-in types. So we already know the int, okay, which is basically our whole number type. Okay, the second type I will talk about is the type double. Okay, now right away, if you're confused by why is it double of what, is there a single? No. Okay, so let me explain to you. This is just a word. Okay, it doesn't mean that much. I mean, yes, there is a point. It means double precision, yada yada yada, but it's really irrelevant for our purposes. Double is a name, just like int. Okay, it doesn't mean 2 of anything. It means double is basically a type that we use for fractional numbers. Okay, so it's that simple. Double is a default type that is like an opposite of int. Int can store whole numbers, double can store decimal fractions. So double can store like 2.5, and 0.0001, those kind of numbers, real numbers, so to speak. Okay, so once again, just like int, we can declare variables like double x, double salary, because I felt like calling it that, double something else. And you can do all the same calculations that I mentioned to you before. Plus, minus, multiply, and divide all work. Modulus, however, will not work. So just remember that. Mod, this guy right here, this guy does not work with fractions. It only works with whole numbers. Okay? Because with fractions, there's no remainder. Okay? So double is real numbers. So int is whole numbers only. Double is real numbers. The third type I will talk about is not really a numeric type per se. Well, it is a numeric type, but it gets interpreted as something else. So the next type is character. All right, it's pronounced char a lot of times, but it actually stands for character. We just don't pronounce it care, because that would be weird sounding. I mean, char, it just comes off the tongue faster. So this is a type called char. All right, a char is a character. A character is basically one character of the English or American or English, whatever you want to call it, standard keyboard. Okay, this is one character, and it's usually represented. Char is usually 1 byte long. exactly, which means it can store 256 different values. Okay, so char is, even though it's kind of a number, it's kind of like an integer number. Okay, so it stores numbers from 0 to 255, but these numbers, they stand for letters of the alphabet and different characters on the keyboard. So normally the way we assign to a char, and here's like a char ch, right? So I'm going to create this character, right? We can assign to it, again, using the equal sign, just like we do with the numbers, but what we can assign to it is the actual character code. And what we do is we use the single quotes. Okay, now remember, I showed you how to use double quotes for strings of things you want to print out. This is single quotes, okay? And single quotes can only hold one character, okay? One whole character. So like, for example, capital A, right? So this character is now capital A. And of course, I can also print it out just like I printed the X, okay? And I can also use it in calculations, but what happens is the A gets converted into whatever its ASCII value is. See, there's this table. It's called ASCII table, if you don't know already. It stands for American Standard Code for Information Interchange. Okay, this table, it gives a number to every character on a keyboard, and then every invisible character like enter and space and escape and all those kind of new line, all those kind of characters. Every character has a number. Okay, they're all numbered. Okay, from 0 to from 0 to 127, and then there's another 128 for the international keyboards. But this is what this uses a lot of times. So I say a lot of times because there is such a thing as implementation defined behavior, which means that some implementations, it could be not an ASCII, it could be something else. But this really doesn't concern us because that's rare. Basically, the idea here is that char variables can store single characters. Okay, so we have int, which is whole numbers, double, which is fractional numbers, char, which is characters. Okay, characters only. Okay, and finally, let me show you the fourth primitive type. Okay, the fourth primitive type is called a bool type. A bool, B-O-O-L. Okay, so bool stands for Boolean. And basically the idea of this is a bool can store, can stand for either true or false. Okay, those are the only choice. So integer variable can stand for all whole numbers. Double can stand for all real numbers, all fractional numbers. Character can stand for any of the characters, okay? And bool can stand for true or false. Okay, literally, it can stand for true or false. And you can even write that out because C++ actually understands the word true and the word false. So you can write bool x equals false, okay, like that. And then you can make it true later on. So this variable is actually, it seems like it's kind of useless because all it does is holds true or false. Okay, but it's actually very, very useful because a lot of times in your program you're going to have these things called switches, and you're going to have a lot of times Boolean is bool variable is what kind of gives you the state, so to speak. Okay, so for right now, that's all you have to understand. A Boolean stores true or false. So those four types of variables are the basis, okay, of every other type. Okay, these four types are called fundamental types of C++. Okay, I'm not going to elaborate in these videos about, there is also such a thing as like long, for instance. There's long, there is those kind of types. There's also a like float, which is the short version of double. All these things are basically variations on the types that I've already said. So for right now, just remember these four types. Okay, remember the int, whole, double, real, all right, fraction, char, characters, and bool, yes, no. That's literally what I wrote. True or false, yes, no. All right. So these are the basic types that we're going to use for most of our variables. Okay. And at this point, I will say goodbye, and I'll see you guys in our next video.